Thermal emission analysis to predict damage in specimens of high-strength concrete. In this paper, thermal analysis was applied to determine the critical stress of concrete, different from its ultimate strength, able to produce the first damage in their structures under compressive loads. The critical stress can be thought as the stress able to produce the beginning of fatigue rupture within the material. Several specimens of high-strength concrete were tested in order to define the incipient crack phenomena, also in internal part of the specimen not accessible by direct inspection, with the aid of infrared thermography. The experimental stress versus temperature curve were obtained in order to identify the critical stress as the change in the linear trend of the temperature signal. An image analysis procedure was performed in order to obtain the specimen thermal map. A finite element analysis was performed to compare the experimental temperature map and the numerical stress map. The results of the research show how the thermal analysis permits to identify the stress that produces the first local cracking in the specimen, with loads different and lower from the breaking load. The loss of linearity in the temperature stress diagram permits to associate the critical stress of concrete to the stress value that define the beginning of fatigue phenomena. A suitable protocol test may be adopted both in the testing stage and in the working stage as non-destructive method to determine the critical stress of the concrete specimen or structured components. Thank you for your kind attention.